So there's no solution to every question.
All right, so for 5a, this is 7.3 PC20, 5a. So solve each equation. Okay, so with this absolute value sign here, we have to consider the negative sort of version of this graph and the positive version of this graph. So we're going to do case 1 and case 2. Okay, case 1 over here, case 2 over here. So case 1 is the positive version, so 2a plus 7 equals a minus 4. Is that good? So let's do this like normal now. We'll subtract an a from both sides, and we'll get, subtract a 7 from both sides, and we'll get, what is that, negative 11?
Yeah.
So would it be negative a then?
It'll be negative 11. No, we're going to subtract a from both sides, so that gives a positive a. Subtract 7 from both sides gives a negative 11. Okay, so we have a equals negative 11. Case 2 is if this part in here, now we got to check this at the end though. This is the thing, got to check this. So this is the negative version let's consider. So that's negative 2a minus 7. You change all the signs of all the terms inside there. Or you take this 2a plus 7 and you just multiply a negative through. That's the negative version. This is what you get. Good? So let's see what happens here. Now, let's add 2a to both sides. We get the positive a term over here. So that's what, 3a. And then we'll add 4 to both sides. That's negative 3. Divided by 3. A is negative 1. Okay. So algebraically, this is what we get. You always should check, because algebra, sometimes if you take these two possible possibilities, negative and positive, sometimes it just doesn't work. You could have graphs that don't actually intersect at all, which would have no solution. So we'll check the graph in a second. But the absolute value of 2 times negative 11 plus 7, does that equal negative 11 minus 4? Well, look what I'm noticing, something right away here, that on the right side, I have a negative value, right? That's negative 15. And if a negative number equals an absolute value of a number, that's not gonna wash. So what's 2 times negative 11? That's negative 22. Plus 7 is absolute value of negative 15. Well, the absolute value of negative 15 is actually not negative 15, right? So this does not equal each other, so I have to reject this solution. Likewise, if I try negative 1, so let's try negative 1 on both sides. Negative 1, negative 1. Well, this is again a negative value, and that equals an absolute value, really? Well, that's negative 2 plus 7. Is positive 5. So we have 5 equaling negative 5. That also does not work, so I reject this one as well. All right? A quick graph, you can use graphing technology to see if you're like totally out to lunch here, because maybe you really screwed up and you know something's really wrong. You could also just graph this. I'll show you again. You can use your graphing calculator or Desmos or whatever, but you know, even if we just kind of give this a quick check, so this regular old line would have positive 7 as an intercept, a slope of 2. So it's going to go up like this. It's going to come down somewhere here and bounce back up. Okay. A minus 4. Well, this is a positive 1 slope with an intercept of negative 4 down here. Look at this. That's that line. Guess what? They don't intersect anywhere. So that's why, again, there's no solutions. Okay? So you're not going crazy. This has confirmed all that. Algebraically, you come up with a number, but you got to check. And graphically, the two graphs don't intersect anywhere, so you have no solutions here. Okay, does that satisfy your question there for 5A? Okay. Anybody else have any questions on this?